Density, and my name is Mrs. Burnett. Density is a ratio that compares the mass of an object to its volume. So when we're looking at density, we have to consider both mass and volume. Here we see solids are closely packed, the atoms are close together. Liquids, they're a little bit apart, but not much, and gases, they're very far apart. So when we're looking at mass, we look at the individual atoms and how much they weigh, and then collectively, how much does the entire substance weigh. And then the volume is the space that it occupies. So the solids, the atoms are closely packed together, and normally we would think of the solid as having the greater of the densities of the three. But there is one situation in which the solid does not, and I'm going to explain that to you further on. And down here we see just some examples of how the atoms in the particular substance is arranged. In gases, they're free to flow until they hit the container. In liquids, they just flow around. They have vibrational energy too. And then in solids, they only have vibrational energy because they're closely packed together and they stay together. Here is an actual photo of atoms. We have diatomic molecules that are made of two atoms, and then we have some singles also traveling around. So this is an actual picture of actual atoms, which is incredible to think that they can actually do that now. So solids, liquids, and gases. What about the density? I love this picture. It was a picture we took on our 30th anniversary. We went on a balloon trip. And I love it because you see the balloon that's in the air. It's traveling upward. For it to do that, that means that the air inside the balloon is less dense than the air outside. And so that's why it was able to travel up. And here's a balloon getting ready to go. And they have a propane tank here, and it sprays out the fire, and the fire heats up the gas inside. And as that gas inside is heating up, the air inside is heating up, it will slowly start to inflate. So it's a hot air balloon. And then I have liquid water, and I have some pebbles here, some stone. And we're going to look at the comparison of the densities of each of these states of matter. First, let's remember that density can be calculated. It is the amount of matter within a measured amount of space. So the amount of matter is measured in grams because it is the mass. We can use kilograms as well, but in chemistry we work with really small quantities, so we usually use grams. And here is a balance that you will be using in lab to calculate the number of grams of the matter that you're working with, or the substance you're working with. We also need to take into account the space that it occupies. So if it's a lot of mass in a little bit of space, it would be very dense. And I think you guys have heard about black holes. Black holes are so dense that not even light can escape the gravitational attraction. The amount of space is measured as volume in milliliters. So here's the graduated cylinder. We could measure it in liters or in cubic centimeters as well. I like to use milliliters. It's a little easier to type out. 1 milliliter equals 1 cubic centimeter. So if I had a box and each side, a square box, and each side was only a centimeter, that little box with 1 centimeter on all sides would be a centimeter cubed. That would hold 1 milliliter of water. Because density is the ratio that compares the mass of the objects to its volume, we can write the equation. And the equation is D equals mass over volume. Density equals mass over volume. I can also write it this way. It might be a little easier to see it if I write it this way. Now, I like to remember it by putting a heart. So I usually draw a heart when I'm doing a density problem, and I put D equals heart. And then all I have to do is just draw a line through my heart. So I know it's mass divided by volume. So if you put down I love density, density, heart, mass divided by volume. So let's take a look at these solid bars. These solid bars actually have the same number of atoms, but different types of atoms. So this one is made out of copper atoms, and this one's made out of aluminum atoms. So the size of the atom and the mass of the atom will determine the density. Copper actually has a greater density than aluminum because copper atoms are close together, they're small, but they're heavy. Aluminum atoms are bigger and they're farther apart, and so it makes it a little less dense. That's why aluminum cans are are pretty light. And then we have marshmallows and rocks. And of course, you guys can all agree that marshmallows are very light. So, and they have a big space. So this one marshmallow is much lighter than even this tiny rock, because this rock is very dense. So let's do a calculation. Compare the density of a marshmallow to the density of iron. First, we want to find the density of the marshmallow. If 12.5 grams fills a 25 milliliter container, we'll begin by writing our equation. D equals m over v. Then we fill it in. 12.5 grams for the mass, 25 milliliters for the volume. Divide 12.5 by 25 and we get 0.5 grams per milliliter. So that was pretty easy. And you guys know that we're heading for a bigger number with the iron, right? Because iron is a lot more dense than marshmallows. So find the density of iron if the same size weighed 197 grams. I'm going to give you a moment to take and try to figure that one out yourself. 197 grams, and it occupies the same space, which would be 25 milliliters. Yes, we write D equals m over v and fill it in. 197 grams divided by 25 milliliters, and that will give us 7.88 grams per milliliter. I hope you guys got that. There's one solid that is actually less dense than its liquid counterpart, and that is ice. The reason that water in the solid state is less dense than in the liquid state is because water molecules are bent, and when they position themselves into crystal form, they actually take up more space. So ice does float, and that's a good thing too, because when the lakes freeze over in the winter, the fish can live underneath the ice. And actually, they're quite cozy down there. So ice is one example of a solid that gets less dense as it solidifies. So iron, if we were to melt iron, the liquid iron would have a little less density than the solid. So taking a look at this, water occupies 1 milliliter at 4 degrees Celsius. So water has the density of 1 gram per milliliter, cold water. Cold water has a density of 1 gram per milliliter. Warm water is less dense. So at 85 degrees Celsius, water's density is 0.968. So hot water is less dense. Now, what happens in nature that this would be important for? And that would be currents. So here we see the surface currents of the oceans, and the red arrows indicate warm water, and the blue arrows indicate cooler water. Now notice, the warmer water flows from the equator to the poles, right? Because the equator is where all the water is getting heated up. So here's where all the water is getting heated up. And it'll flow toward the poles, and then the colder water from the poles will flow upward toward the equator. And down here, the colder water from the poles will flow down toward the equator. So that's where we get our ocean currents. And here's Florida right here. So we have warm currents that flow, and it warms up the land. And here, Africa gets cooled by the colder currents. So they probably welcome the cold currents because the equator is down here. So that those currents also help to distribute the salt in the oceans. Gases have density as well, right? Because gases are made up of matter. Our air is made up of 78% nitrogen, 21% oxygen, and 1% carbon and other compounds. And so when that air is heated, it can become less dense. Or if we have other gases present, that can also be dense. So when you spray perfume, that gas is heavy. So that's why it goes downward. So it's always good to spray up and walk under your perfume if you want to put perfume on instead of spraying downward. So let's take a look at a gas application. Compare the density of the air you breathe of the regular air to the density of the air you breathe. So if air is 78% nitrogen gas, I'm just going to assume that the density is made from the nitrogen gas. We see that we have 22.4 liters of nitrogen gas, weighs about 28 grams. So we put in our equation, D equals M over V. Density of the nitrogen is 28 divided by the 22.4 liters. And we get a density of 1.25 grams per liter. So 1,000 milliliters makes a liter. So we're looking at a very low density, right? Because this would have to be over a huge space, a whole liter of space. I just didn't want you to get confused because we used milliliters before. Carbon dioxide, on the other hand, weighs 44 grams. And so it occupies the same amount of space, 22.4 liters. So its density is calculated to be 1.96 grams per liter. So when you breathe out, would your air rise? Does your breath air rise or does it sink? Well, here's a picture of a person breathing in cold air. I thought it would be help you to see what happens is the water vapor from his breath is actually crystallizing because it's cold, and that's why you can see the breath. But notice it's not going up. It goes down because carbon dioxide is heavier and heavier than the air that you breathe. So it goes down, which makes sense because plants need carbon dioxide to grow, and the most abundant plant is grass. And grass is low to the ground. So let's look at some practice problems. Calculate the density of a piece of bone with a mass of 3.8 grams and a volume of 2.0 cubic centimeters. We're going to start out by writing the equation and then filling it in. So we write out the equation, D equals M over V. Mass is 3.8 grams. Volume is 2, and I put milliliters there because these are interchangeable, remember? And then I'm dividing it out. So it's 1.9 grams per milliliter. Practice problem number 2. A spoonful of sugar with a mass of 8.8 grams is poured into a 10 milliliter graduated cylinder. The volume reading is 5.5 milliliters. What is the density of the sugar? Now in this one, we're using a 10 milliliter graduated cylinder. And from my previous videos, you learned that 10 milliliters is just the size of the graduated cylinder. So it is part of its name. So that 10 doesn't mean that they're pouring it into 10 milliliters. It just means that that's the size of the graduated cylinder. But only 5.5 milliliters is the reading of the sugar. So we're going to use 5.5 milliliters as our volume. I'll give you a moment to figure it out, and then we'll look at the answer. So you wrote down the equation, D equals M over V, and you fill it in, 8.8 grams divided by 5.5 milliliters, and you see that the density of the sugar is 1.6 grams per milliliter. That'll be the same density regardless of how much mass you have, because the more mass you have, the more space it's going to occupy. So density is an intrinsic value. It does not change. It will always stay the same for that substance. Now, each substance has a different density. Just like we see here, the bone's density is 1.9, whereas the sugar's density is 1.6. So each substance has its own density, but that density doesn't change. It doesn't matter how much you have. Whether you have a truck full of sugar or a spoonful of sugar, it's still 1.6 grams per milliliter. Our next problem, practice problem number 3, a 10-gram pat of butter raises the water level in a 50 milliliter graduated cylinder by 11.6 milliliters. What is the density of the butter? Again, I'm going to give you a moment to do the work, and then I'll come back and show you the answer. Right, you probably wrote D equals M over V. Density is 10 grams divided by the 11.6 milliliters, and we see that our density is 0.862 grams per milliliter. If you didn't get that right, go ahead and put the tape back and try it again. And just practice these problems until you understand them. Let's look at practice problem number 4. Rock salt has the density of 2.18 grams per milliliter. What would the volume be of a 4.8 gram sample of rock salt? I'm going to give you a hint. You're still going to use the same equation, but you're going to solve for a different unknown. I'm going to give you a minute to try to work it on your own. So you wrote the equation D equals M over V. we see that 2.18 grams per milliliter equals 4.8 grams, and we're solving for V volume, so volume is on the bottom. Now when we do our algebraic manipulation, volume would come to the left side of the equation, and the 2.18 would be brought over to the right side. So it's 4.8 grams divided by 2.18 grams per milliliter. The grams can cancel. Oops, this line should be over here on the grams. The grams are the ones that are canceling. My lines must have been off a little bit. Let me put those back over there. Yeah. So our grams are going to cancel, and then we're going to divide it out. So we divide it out as 4.8 divided by 2.18, and our volume is 2.20 milliliters. Remember, because of significant digits, we have 3 digits. Our answer needs to have the 3 significant digits, even though this is a 0. This 0 is significant because it's after the decimal, after the whole number. Well, I hope that you enjoyed this video and you learned a lot. I thought this picture was wonderful. I took it when we were on our balloon trip, and it shows the 2 balloons off in the distance, and you can see the horizon. And a meteorologist friend told me that this is the Saharan dust that comes over the horizon, because we're looking out toward the Atlantic Ocean. So he said it's interesting that we were able to see that. And then there was a hang glider up there too, and it was very quiet. So it reminded me of the verse in Isaiah that says, "But those who wait on the Lord shall renew their strength. They shall mount up with wings like eagles. They shall run and not be weary. They shall walk and not faint." Eagles don't flap their wings. They soar on the wind currents in the air. When we were in that hot air balloon, it was absolutely silent up there. And that's how a eagle is. He's soaring up in absolute silence as the air currents, because of the temperature in the air, colder air sinks, hot air rises. The eagle is able to soar or mount up with wings on their wings. They don't flap. So I hope that this helps you understand density and its application. And we're going to do a little activity called Will It Sink or Will It Float? See you in class.